This section is a trigonometry review, and I'm assuming that you know the unit circle. However, if you don't know the unit circle or use right triangle trig, there is a worksheet that you can fill out. If you go to the course website under Math 123, under Unit 1 Video Lectures, you'll see that right next to the video that I'm creating right now that will go here, I have two things. The first thing is a blank copy of the unit circle. So if you're used to using unit circle trig, you can go ahead and fill this in. Cosine and sine go here for all of our angles. These are standard angles. And if you need a bit of a review and need a solution, right next to it is a solution filled out, so you can double check all of your information. Remember, the first value is cosine, second value is sine. This is assuming that this is the unit circle, meaning the radius is 1 from the center or the origin here to the outside on any point on the circle. If you're used to using right triangle trig, that's fine too. You can go ahead and stick with that. I'll be interchanging between unit circle trig and right triangle trig, kind of depending on what is easier for the particular problem that we're working on. So to get started, let's go ahead and keep that circle in mind. That right triangle trig we can bring up as well, but we're going to look at the unit circle here. So to get started, we're used to some things like sines and cosines. We usually use a Greek letter to represent an angle like theta or alpha or beta. So we're used to some things like sines and cosines that we're working with. Well, there's some other trig ratios based on sines and cosines as well. For instance, sine of theta, the reciprocal of sine of theta is cosecant of theta. So the cosecant of theta is 1 over sine theta. Secant theta is 1 over cosine theta. And then we can also talk about tangent theta. Tangent theta is the ratio of sine over cosine. And I'm pretty particular about putting parentheses around the arguments of your trig functions. And we'll see some problems a little bit later on in this lesson to show why that's so important. But please always put arguments in parentheses. And then cotangent theta, I can think of one of two ways. I can think of it as cosine over sine, cosine theta over sine theta, or 1 over tangent theta, the reciprocal of tangent. So these are several trig ratios that we're going to definitely want to know. Now also along these lines, if you're used to using right triangle trig, we kind of use the acronym SOHCAHTOA as well to work with right triangle trig. So what this means is the sine of theta, if I have a right triangle, is equal to the opposite over the hypotenuse side. The cosine of theta is equal to the adjacent over the hypotenuse side. And the tangent of theta is equal to the opposite side over the adjacent side. It's the ratio of those. So I can use these values for SOHCAHTOA and using our right triangle trig in these relationships to kind of help us out a lot. So these are going to be important to know. If you're used to working with unit circle trig, let's think about sine theta is y over r. R is the radius. Cosine theta would be x over r. R is the radius. And of course, all of these ratios would follow from there as well. So we'll be looking at a combination of unit circle and right triangle trig depending on the problem that we're looking at. Let's go ahead and look at a few basic ones. You'll want to have the unit circle memorized. It's going to come in handy to know these values. If you are working on a homework or a quiz, of course, you have your calculators. Your calculators give you radians, but they give them in decimals, and you'll always want your answers in exact radians. So that's why it's so important to know the unit circle. So let's go ahead and look through a few examples. Cosine of 4 pi over 3. Now, I don't really know what the cosine of 4 pi over 3 is, but I can figure it out. If I look at 4 pi over 3, and I'm thinking about where this angle is, if I go this far, I know that I've gone pi or 3 pi over 3, and I need to go another pi over 3 to get to 4 pi over 3. So this angle that I have right here is 4 pi over 3 that I've drawn. Now the reference angle is the angle back up to the horizontal axis is pi over 3, and I don't care about its direction. I don't care if it's positive or negative. I just care about that it's pi over 3 units back to the horizontal axis. So I use the idea of reference angles when I'm looking at these. I have the first quadrant memorized of my unit circle. So I know if I'm talking about pi over 3, I know that the cosine of pi over 3 is 1/2, and the sine is square root of 3 over 2. So I can use this information to help me find the cosine of 4 pi over 3. So again, I just usually have my first quadrant memorized, and then I kind of work off of that. Well, the cosine of 4 pi over 3 has a reference angle of pi over 3, and the cosine of pi over 3 is 1/2. Next thing I do is I look to see that I'm in the third quadrant where cosine is negative. So the cosine of 4 pi over 3 is negative 1/2. And again, there's a lot of different ways to do this. You can go into right triangle trig if you want to here, or use this first quadrant of the unit circle similar to what I did. But you need to be able to find these sines and cosines that we're going to be working with. Let's go ahead and look at a few others. We'll look at some basic ratios. Let's look at the sine of negative 7 pi over 6. And again, I'm going to graph this first, figure out which quadrant I'm in, and then from there I'll figure out if my sine of negative 7 pi over 6 is positive or negative. Now I'm starting at 0, and then I'm moving in the negative direction because it tells me I should. So negative 7 pi over 6. Here's negative 3 pi over 6, because that's the same as negative pi over 2. Okay, so negative 3 pi over 6. Here's negative 6 pi over 6, because this is going to be a negative pi if I'm moving in this direction. So I have to go up another pi over 6. So this gives me my angle of negative 7 pi over 6. So if I want to think about this as negative 6 pi over 6, I can as well. So it gives me that little bit of an idea. Now my reference angle, and this idea of reference angle is going to be really important, is pi over 6. How far is it to the nearest horizontal axis? Well, I know the sine of pi over 6 is 1/2, because I have that part of my first quadrant memorized. So again, this is my first quadrant. This is pi over 6. So I have square root of 3 over 2 and 1/2 here memorized. Now, when I'm trying to look at this, I'm trying to think, okay, I'm in the quadrant 2. Sine is positive in quadrant 2. So my solution here is just 1/2. Now, if you plug this into your calculator to double check your answers, make sure you're in radian mode and that you're not in degree mode, because you will get incorrect solutions. Let's go ahead and look at a few others. And again, I always graph these first just to kind of give me a quick visual. And then once they're graphed, they're pretty straightforward to work with. Let's go ahead and look at the secant of 5 pi over 4. Secant 5 pi over 4. Okay, so first of all, I want to figure out where this is, 5 pi over 4. So if I start here at 0, here's pi over 2, 3 pi over 4, 4 pi over 4, 5 pi over 4. So this is the angle 5 pi over 4. Okay, so I'm trying to figure out what this angle has, the secant of this angle is. Well, let's think about a couple other things. Secant is 1 over the cosine of 5 pi over 4. And I know that in quadrant 3 that the cosine is negative. So I know my answer is going to be a negative here, and I kind of have that taken care of. Now again, I know my unit circle in that first quadrant. So in the first quadrant at pi over 4, my reference angle here would be back pi over 4. My cosine and sine are square root of 2 over 2 and square root of 2 over 2. So this is square root of 2 over 2. So it's negative because I'm in the third quadrant, 1 over the square root of 2 over 2. Now, you're never going to leave your answer like that. When you divide by a fraction, you multiply by the reciprocal. So this is negative 2 over root 2. And then we rationalize, and I'm left with negative 2 root 2 over 2. The 2's cancel, and I have a negative root 2. Now, a lot of your calculators don't have secant on it, so you'll have to double check your work with the cosine. But again, take a minute, write these out, sketch these out, draw that quadrant, graph where the point is, and it will be really helpful trying to come up with the correct solution. Let's look at cosecant of 7 pi. Cosecant of 7 pi. Now this is a multiple of pi, so we have to kind of keep track here. If I start at 0, this is 1 pi if I'm moving in the positive direction. This is 2 pi. Here's 3 pi, 4 pi, 5 pi, 6 pi, 7 pi. So 7 pi has a reference angle just good old pi. So if we talk about the cosecant, this is a quadrantial angle, and because it's a quadrantial angle, I'm going to have either a value of 0 or 1 here. But let's think about what cosecant is. Cosecant is 1 over the sine of 7 pi. Well, on this angle right here, the sine is going to be 0. This is the ordered pair, cosine -1, sine of 0. So 1 over 0 is undefined. So when I'm talking about finding the cosecant of 7 pi, if you were looking at a calculator, it would probably say error or incorrect domain or something like that. But we know it's undefined because we can't take 1 and divide it by 0. So sketching that's going to be really helpful. And again, don't rely on your calculators. Make sure you know how to work with your unit circles. Let's go ahead and look at the cotangent of -5 pi over 2. So again, cotangent we know is going to be either 1 over tangent, if you want to think about it like that, or cosine over sine if you have that ratio memorized. So cosine -5 pi over 2, or the sine of -5 pi over 2. Okay, now let's go ahead and graph this. Now we're moving in the negative direction this time. So we're going to start here, -pi over 2, -3 pi over 2. So again, we're keeping track of pi over 2. So -pi over 2, -1 pi over 2, -3 pi over 2, -5 pi over 2. So this angle is -5 pi over 2. Well, if we think about what the sine and cosine are for this, the cosine of -5 pi over 2 is going to bring us down to the x value, and the x value we can see doesn't move off the origin. The y value is going to be a -1. So 0 over -1 is 0. So the cotangent of -5 pi over 2 is 0. So knowing your unit circle is going to be really helpful when you're working with these. Let's look at one last problem. Let's look at a tangent problem. So tangent, let's do -5 pi over 6. Okay, so tangent is sine over cosine. That might help us out here. And again, I don't have the tangents memorized. I just know the ratios, and I can always work back from my unit circle. Okay, so let's go ahead and graph this. This is in the negative direction, so I'll start here. -3 pi over 6, -4 pi over 6, -5 pi over 6. Now our reference angle here is the distance to the nearest horizontal, would be pi over 6. And I don't care that it's positive or negative. Now another thing I noticed down here in the third quadrant, that's where this angle lies, is both sine and cosine are negative, so my ratio for tangent should be positive. So sine of -5 pi over 6. My reference angle is pi over 6, so the sine should be -1/2. Cosine is -√3 over 2 for that pi over 6. Now when you divide a negative by a negative, you get a positive. When you divide by a fraction, you multiply by the reciprocal. So I reciprocate √3 over 2. The 2's cancel, and I'm left with 1 over √3. Now we usually rationalize these denominators, so I'm left with √3 over 3. So the tangent of -5 pi over 6 is √3 over 3. Now, if we want to use our calculators to check our work, that's okay. Just make sure that you don't rely on your calculators to do your work, because you are going to have to know the unit circle. So let's go ahead and check this problem. We're looking at tangent here. So on my calculator, here's tangent. Wait a minute, let's make sure we're in radian mode, and I am. So tangent, and we want to go -5 pi over 6. And if you have a fraction key, feel free to use that as well. Now this doesn't give me, this is radians, but it's not an exact radians using ratios of pi's. So I want to kind of scoot back here, and what did I get for my answer? √3 over 3. So let's see if we get √3 over 3 in decimal form to be equivalent. And you can see that they are equivalent, so I do have the right solution. But the answer that will be accepted on homeworks and quizzes and exams and handwritten homeworks is the √3 over 3. We need that exact form. So that's a quick review of using the unit circle. And again, this is assuming that you either have the unit circle memorized or you're really quick with your right triangle trig. Next thing we're going to do is we are going to use this knowledge of the unit circle to solve some trigonometric equations. So let's look at a trig equation. Let's go ahead and look at something like tangent of x equal 1. Now when we're solving trigonometric equations, we usually need one other piece of information. Sometimes you might say on the interval 0 to 2 pi or 0 to pi. But this one is saying, okay, let's go ahead and find x. And then over here it says plus pi k. So it's telling me to find the general solution and then look at integer multiples of pi to find the rest of my solution. So that's how I'm going to start here. Now there's several ways that we could solve this. One thing that we could do is we could rewrite tangent as sine over cosine. And I have sine over cosine equals 1. I could multiply both sides by cosine. And again, this is just one approach. And here I get sine of x equals cosine of x. Well, if you know your unit circle, you know that that's only going to happen in one place, and that's at pi over 4. So if we think about letting x equal pi over 4, then the sine of pi over 4 equals square root of 2 over 2, and the cosine of pi over 4 equals square root of 2 over 2. So we can see that they're equal here. So if I wanted to, I could use pi over 4 for my solution, just because of my knowledge with the unit circle. Now, you could also talk about inverse trig functions. So tangent x equal 1. So a lot of times what people do when they're solving for these is they'll take the inverse tangent of both sides. So inverse tangent of both sides. Now what happens with the inverse tangent of the tangent of x is these ideas cancel and I'm just left with x. And then over here I get the inverse tangent of 1. Now inverse tangent is asking me a question. This means what angle has, actually let's put our restriction in first. What angle in the interval negative to positive pi over 2, I want to make sure I get my notation right here. And again, this is a restriction that you had memorized from trigonometry, has a tangent of 1. And you would answer and you would say the angle is pi over 4. Okay, so we can go through the inverse tan process as well. Now, if you solve this on your calculators on the right hand side of the equation, if you put in inverse tangent, let's see what we would get. So my inverse tangent is up here, so second inverse tangent of, I think it was 1. Let's see what we get. It does not look like pi over 4. However, if I checked my answer, you can see that they do match. So it is pi over 4, but I need that exact form. So again, I get that pi over 4 up here. Now, this is going to happen in the first quadrant where tangent's positive, and there's going to be another answer in the third quadrant, and that's where this pi k comes in to move me into the third quadrant. And then it's going to happen again in the first quadrant as I keep going around. So it's important that you understand the idea behind multiple solutions, and this notation takes care of those multiple solutions. Let's go ahead and look at another interesting equation. There's so many good ones. Let's go ahead and look at 12 sine squared theta equals 3. So the first thing we'll want to do is isolate the sine of theta, so we'll divide both sides through by 12. And I get the sine squared of theta, 3/12 reduces to 1/4. Now to get sine squared theta down to sine theta, I'd take the square root of both sides, and I'll have the sine of theta equals, remember I have two roots here, plus or minus, the square root of 1/4 is 1/2. So I really have two equations that I go after here. I have the sine of theta equals positive 1/2, and then I have this other equation, the sine of theta equals negative 1/2. Now for this one, we should have had a little bit more information, so let's go back up and annotate that. Find the solutions on the interval. And it's pretty typical to look at a problem like this and maybe go 0 to 2 pi. Now notice that 0 has an equal sign and 2 pi doesn't, so I have to make sure that I meet those requirements. Now, where is sine going to be positive? Where is sine theta going to be positive? So I have a positive sign in the first and in the second quadrant. So I need an angle from the first quadrant. What angle in the first quadrant has a sine of 1/2? That would be pi over 6. And then I need an angle from the second quadrant. What angle in the second quadrant? Well, it'd be our angle that has a reference angle of pi over 6, which would be 5 pi over 6. Okay, so that's pi over 6 here, 5 pi over 6 over here. So there's two solutions. Now over here on my next graph, this is saying sine theta is negative. So sine theta is negative in the third and in the fourth quadrants. So I will have an angle here, and I'm not going to use a negative angle because this says my angles have to be between 0 and 2 pi. So I'll have this angle, and then I'll have this other angle as well. So one angle would be 7 pi over 6, because again, here's 6 pi over 6, 7 pi over 6. And then this would be 12 pi over 6 over here. And I have to back off 1 pi over 6 to get down to that reference angle, so that would leave me at 11 pi over 6. So these are my four solutions, and usually when we write our solutions, we write them in order from largest to smallest. So here our solution would be theta equal pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And again, you can check these on your calculator, but you'll be required to have your solutions in exact form on homeworks and quizzes, handwritten homeworks, and exams. So an example of where we can look upon those intervals to find these. Let's go ahead and look at another equation that we can solve. Let's look at tangent squared of 2 theta. This one's a little bit more involved. Tangent squared, notice the argument's not just a theta, it's a 2 theta equal 3. Now we're solving this equation on the interval between 0 and pi. Now notice I have equality at 0, and let's put equality at pi as well. So if I wanted to graph this function, I could, but I'm just going to go after my knowledge of the unit circle to get me started. So let's go ahead and think about tangent squared of 2 theta equal 3. I would like to get tangent 2 theta by itself, so I'll take the square root of both sides. The square root of tangent squared of 2 theta is just tangent of 2 theta. Now over here on the right hand side, I'll have plus or minus the square root of 3. Now the reason we have the 2 roots there, remember, that goes back from squaring root 3 will get me to 3, and squaring negative root 3 will also get me to 3. So tangent 2 theta equals plus or minus root 3. Now I have two equations that I need to work off here, and again, knowledge of my unit circle is going to be crucial. So tangent 2 theta equals the square root of 3, and then my other option would be the tangent of 2 theta equals negative square root of 3. Now, I know something about tangents. I know that this looks familiar. This could be a standard angle for me. So let's think about tangent off to the side here for a minute. Tangent, let's just say of some angle alpha, is sine over cosine. Well, if I look at the ratio of square root of 3 over 2.5, this ends up being the square root of 3 over 2 times 2 over 1. This gives me that square root of 3 that I'm looking for. But what angle has a sine of square root of 3 over 2 and a cosine of 1/2? Well, because I know my unit circle, I know that that angle is pi over 3. So that tells me that 2 theta has to equal pi over 3. Now the reason that it's positive pi over 3 is because tangent is positive, and tangent is positive in the first quadrant, and it's also positive in the third quadrant. Now, we do need to take into account this third quadrant business, and that would be taken into account by k pi. Because I have an angle here, and then another 180 degrees or another pi rotation will put me down into the third quadrant for the next solution. So let's go ahead and stick with what we have here, and then let's talk about what we have going on over here. Over here, 2 theta would be equal to, let's think about this, negative root 3. Okay, tangent is going to be negative in the second and the fourth quadrants. So if we look at 2 theta, and we're trying to figure out that solution, it seems like to me we should come clear over here into the second quadrant to get to that negative tangent. So that would put us at 2 pi over 3. So 2 theta equal 2 pi over 3. And then I'll have to look at that k pi multiple again to pop me into the fourth quadrant. Now again, we want to know what theta is, so I'm going to divide both sides through by 2, every single term through by 2. So I'm going to get theta equal pi over 6 plus k pi over 2. Over here I'll divide through by 2 as well, and I'll get theta equal 2 pi over 6 plus k pi over 2. Now I can reduce the one on the right, so let's go ahead and rewrite both of these. And over here we'll have theta equal, now 2 pi over 6 reduces to pi over 3 plus k pi over 2. Now we wanted our answers between 0 and pi, so I need to keep working this a little bit. So what I need to plug in some values of k. So let's go ahead and plug in some values of k just to figure out where my solutions are. Now what I want to do on either end is I want to find a solution that doesn't work, that's out of the interval, and then one that does, and then all the solutions in between are my answers. So for this equation, if I plug in k equal negative 1, I'm going to have theta equal to, let's go ahead and run through this, negative pi over 2. Okay, so negative 3 pi over 6 would be equivalent. Pi over 6 minus 3 pi over 6 would be a negative 2 pi over 6, which is a negative pi over 3. Okay, so if you need to pause and run through that one more time just to convince yourself, that's great. K equals 0. If I plug a 0 in here, this term goes away and I'm just left with theta equal pi over 6. If I plug in a 1, pi over 6 plus pi over 2, but pi over 2 is the same as 3 pi over 6. Pi over 6 plus 3 pi over 6 is 4 pi over 6, which is 2 pi over 3. Now so far this is not in my interval, but both of these are. We need to go one more until we find one that's not in the interval. So if I plug a 2 in here, the 2's cancel, and I'm left with pi over 6 plus pi, which is pi over 6 plus 6 pi over 6, which is 7 pi over 6. So this one's too big. It's outside this interval right here. This one's too small because it's outside this interval as well. So these two are my solutions. Now I'm going to do the exact same thing for k equal negative 1, k equals 0, k equal positive 1, and k equal 2 over here. Now we'll start with plugging in k equal negative 1. So you're going to have to be kind of good with your mental math here, or you can plug these in or do some scratch work on the side. So if I take pi over 3 and I plug in a negative 1, I'm going to have pi over 3 minus pi over 2. Need that common denominator, which would be a 6. So this would be 2 pi over 6 minus 3 pi over 6 would be a negative pi over 6. Okay, and then from here, when I plug in that 0, this is my easy one. I just get pi over 3. Let's go ahead and plug in a 1. If I plug in a 1, I'll have pi over 3 plus pi over 2. So this will be 2 pi over 6 plus 3 pi over 6, which of course will give me that 5 pi over 6. Now both of these are still in this interval up here. Let's go ahead and plug in a 2 next. If we plug in a 2, we'll have pi over 3 plus 2 pi over 2. The 2's cancel, and I'm left with 4 pi over 3, which is outside the interval. So what I have here, this is too small, this is too big, and the ones in the middle are my solutions then. So my overall solutions to this equation we'd like to list in order from small to large would be pi over 6, pi over 3, and then 2 pi over 3, and 5 pi over 6. And again, these are in exact radian measures. They're not decimals. We always want them in exact. And the expectation is on your homeworks and quizzes, handwritten homeworks and exams, your solutions will also be exact. So solving these sometimes takes a little bit of work thinking about the unit circle and doing a little bit of algebra to these equations in order to solve before you can get to that solution. Another good problem to review for trigonometry is looking at given information about a trig function, and then based on that information you need to find all the other trig functions. So for instance, you could have a problem, let's say like secant theta equals 25 over 7. And we're also given the information that theta is between 0 and pi over 2. And basically this just means quadrant 1. So this information, 0 to pi over 2, just basically means Q1. So if I wanted to start drawing out what's happening here, we could draw something up in quadrant 1. So I know I'm in the first quadrant. I'm going to use right triangle trig here for this one. So I have some angle theta to get started with. Now let's think about this. I don't know much about secants other than secant is 1 over cosine. So let's start with that. So we know secant theta is 25 over 7. And I know that cosine of theta is 1 over secant theta. Or if you want to think about it, secant theta is the same as 1 over cosine of theta. So if you wanted to, you could cross multiply and solve for the cosine of theta, but the upshot is they're reciprocals of each other, so the cosine is 7 over 25. Now I'm going to use that idea of SOHCAHTOA. So what I have here is the cosine, because this is the cosine, is equal to the adjacent over the hypotenuse on the right triangle I just drew. So adjacent would be this leg right here. It's adjacent to the theta angle. So that would be 7, and the hypotenuse would be a 25. Now because this is a right triangle, I can use Pythagorean's theorem. Pythagorean's theorem says leg squared plus leg squared equals hypotenuse squared. I'll call this leg y because it's vertical, so it's moving in the y direction. So Pythagorean's theorem, 7 squared plus y squared equals 25 squared. 49 plus y squared equals 625. Subtract the 49 from both sides and have 625 minus 49, which is 576. Take the square root of both sides and I get y equal plus or minus 24. Now, I use the plus 24 in this case because I'm in the first quadrant. But if I was in the third or the fourth quadrant, I would use the negative 24. So you have to make sure you choose, just don't always go with the positive. Now we should be able to write all of our trig functions. So we have a start. We know secant theta was given. And please always put arguments of your trig functions in parentheses. It just clarifies what the argument is versus what the value is. And when we get into arguments that are not just theta, it's going to be important. Cosine is the reciprocal of secant. Let's go ahead and look at sine next. Now using that SOHCAHTOA again, sine is the opposite. So here's my theta. Opposite leg is 24. Adjacent is 7, but the hypotenuse is 25. So SOHCAHTOA, opposite over hypotenuse, would be 24 over 25. Now once I know the sine of theta, I can talk about the reciprocal of sine, which is cosecant. Cosecant of theta is the reciprocal of sine, so that's 25 over 24. Tangent theta, going after that SOHCAHTOA again, tangent is going to be opposite over adjacent, opposite of 24, adjacent is 7, hypotenuse is 25, so opposite over adjacent would be 24 over 7. And then cotangent of theta would be the reciprocal of tangent, so that's 7 over 24. Now all of these values are positive because I'm in the second quadrant. If I was in the second, third, or fourth quadrant, I might have to make some adjustments with positive and negative signs. So be careful when you're working on these. Be careful when you're working on these to double check which quadrant you're in. Now if you use the unit circle approach to this, that's fine too. You probably used when you got started something like sine of theta is y over r, cosine theta is x over r, and then started kind of working backward from there. We'll get the same answers in the end. Now when you're doing your handwritten homework, you're asked to draw a secant line. And I want you to be aware that the secant line that we're talking about is not the graph of the secant function. So on your handwritten homework, you're asked to graph something like the cosine of pi t, and then find the line secant through 2 points. So for an example, to help you get started with that, let's go ahead and graph s of t. And I'm going to graph sine of pi t instead of the cosine. You guys have cosine on your assignment. And I want to draw a secant line and find the equation of the secant line. And I will pick some points here in a little bit. Let's just worry about graphing this first. Now when we're graphing the sine of pi t, it's not just the good old sine graph. Let's think about what the sine graph looks like. The sine of just t, you could plot a few points if you wanted to from here. The sine of 0 is 0. And I'm going to go out by quadrants here. So pi over 2, pi, 3 pi over 2, and 2 pi. And then I'll go in the negative direction. So the sine of 0 is 0. The sine of pi over 2 is 1. So I'm going to call this 1. The sine of pi is 0. Sine of 3 pi over 2 is negative 1. And here's 2 pi. Now the same pattern will continue in this direction. The sine of negative pi over 2 is negative 1. Sine of negative pi is 0. So if you know your unit circle, it'll be really easy to graph your trig function. So here's just the sine of pi t. And I guess I should be careful and not put arrows on the end of those because they don't extend out indefinitely in the positive direction. They follow this same pattern. So that's probably better. Okay, so this is the graph of sine of t. Sine of pi t, I'm going to have to make a bit of an adjustment. And that adjustment will be plugging in values of t because this pi has the effect of taking and changing the compression on the horizontal axis. Okay, so the way that we would graph this is we just choose some values of t. Now some values that we could look at, I'm going to start in the negative direction. Let's do negative 1. Let's look at negative 1/2, 0, 1, 1/2. Oops, let's put these in order. 1/2 and 1. And we'll see if this is enough to get us started. And then let's look at s of t. So if we plug a negative 1 in here, I get the sine of negative pi. The sine of negative pi is 0. And I can look on this graph to see that. If I plug in a negative 1/2, the sine of negative pi over 2 is negative 1. If I plug in a 0, the sine of 0 is 0. If I plug in a half, the sine of pi over 2, because if I plug a 1/2 in here, I get pi over 2. The sine of pi over 2 is going to be 1. And if I plug in a 1, the sine of pi times 1 is pi, is 0. So we can see if that will help us do this curve sketch. And again, it is a sketch. Now once I get the general shape of my graph, I know that that's going to continue on. So hopefully I can eyeball that pretty fast. So let's look at 1/2, 1, and I can continue on with that same pattern. So this would be 3/2 and 2. Now on your handwritten homework assignment, these are decimals, 0.5, 1, 1.5, etc. So this would be a negative 1/2, negative 1, negative 3/2. Okay, so let's plot the point t equal negative 1, so negative 1, 0. So this is my t graph, and this is s of t that runs vertical. If I plug in a -1, I got a 0 back. If I plug in a -1/2, I get a -1 back. Plug in a 0, I get 0 back. And if I plug in a 1/2, I get my 1. If I plug in a 1, I get 0. And you can see that it's the same basic pattern. The only thing that's changed here is my scale. So the difference is the scale. They'll have the same shape. Whoops, kind of missed that one a little bit. Okay, so it'll have the same shape. The only thing that's changed here is my scale. Now, let's go ahead and find some points where I could be secant to the graph. Now, secant means it crosses the graph at 2 spots. Tangent means it touches at 1 spot. So the points that I want to look for, my secant lines, I'm going to choose s of 1/2. So 1/2, s of 1/2 would be 1 point. And the other point I want to choose is 1 and s of 1. So here's 1/2 s of 1/2 right here. And here's 1 s sub 1. So what I'm looking for is this secant line. So I'm looking for the equation of this secant line. Well, we already know how to write equations of lines. I have 2 points here. I just need to find the slope between them and kind of continue on from there. And I also have this ordered pairs, 1/2, 1. I get that from right here. And I also have this ordered pair as well. It's 1, 0. And that comes from right here. So to find that equation of the line, you'd find the slope. You would choose a point, either one, and use your slope. And eventually, you're going to get this equation written in y equal mx plus b form. So this kind of gives you a start on that handwritten homework assignment. Remember, for your homework assignment, you have cosine pi t, so make sure you make that adjustment. Your graph will definitely look different than this. Good luck as usual, and if I can be of any help, please email me, text me, send me a screenshot of your questions, or use your Pearson Connect, or make an appointment with me and we can set up some online office hours. Good luck.